Are you a student struggling to keep up with your lessons? Or a parent searching for a reliable educational resource that truly cares? You've come to the right place. Welcome to FEUNIX Distinctions, your premier channel for educational content designed for every learner. We understand the silent struggles that often go unnoticed, the frustration of slow-paced learners, and the need for solid foundations for all students. At FEUNIX Distinctions, we don't just teach. We are dedicated to guiding you every step of the way. Our teaching style is unique, simple, and incredibly effective. We make complex concepts easy to grasp and ensure that every lesson is both suitable and enjoyable, no matter your learning pace. Whether you're a fast learner looking for a new challenge or an average learner aiming to excel, our comprehensive methodology is built to support you. Join a community where no one is left behind. Subscribe to FEUNIX Distinctions today and hit the notification bell so you never miss a lesson. Let's make learning an exciting journey together.
I welcome you to today's class. This is SS2 class, and we're moving on to lesson 5. In lesson 5, we are going to start a new topic, that is cycle geometry. In cycle geometry, we are going to be seeing chords and arcs. Before we solve any example, I would like to explain some basic parts of a cycle so that we can know these very chords and arcs. We are going to be working with chords a lot. I'm going to draw a cycle so that we can see the basic parts of a cycle. Right here is the cycle. This is a cycle. I'm going to draw the other parts of it. If this is the center of a cycle, a line that runs through the center of a cycle from circumference to circumference is called what? It's called the diameter. That's the diameter. Half of a diameter, that is from center to circumference, is the radius. This is the radius of a cycle. I repeat, from circumference to circumference, passing through the center, a straight line that runs from circumference to circumference of a cycle, passing through the center, is diameter. While from the center of a cycle to the circumference is radius. So you can see the radius of a cycle is half of a diameter. If you have another radius, that is, you have a radius here, you have another one here. The two of them we call the two radius radii. So the two radius give us a space here. This space is called sector. Please, these things are very important. That's the sector. Now let's move on to chord. That's the major part that we need for this work today. A chord is a straight line that runs from circumference to circumference. It must not necessarily pass through the center. A line that runs from circumference to circumference through the center is diameter. A line that runs from circumference to circumference, it could pass through the center, it might not pass through the center. That line is chord. So you can know the little difference between a chord and a diameter. So this is a chord, and the cycle itself is the circumference. That's the circumference. Now there is a portion here. This portion here is called segment. That is to say, when you have a chord, that is this very line, and then this portion of the circumference, that is from here down to this very point here. From here to here is the portion of the circumference. So any portion of the circumference of a circle is called the arc. So the point we are trying to make here, two major points: the chord and also the arc. The arc is the fraction of the circumference. The circumference is the entire cycle that is going round. Any portion of this circumference is called the arc. Let's say from here to here, this is a portion of the circumference. And what do we call this? We call it arc. So with this, we are going to move on to some basic theorems in solving cycle geometry. We will start with theorem 10. Theorem 10. Why is it called theorem 10 and not theorem 1? Theorem 1, 2, 3 up to theorem 9 is in SS1 scheme of work. So in SS2 scheme of work, we start from theorem 10 and then we'll build on and on. This is what the theorem said. A straight line drawn from the center of a cycle to bisect a chord which is not a diameter is at right angle to the chord. Yes. Let's explain this. We'll still draw a cycle and then have our explanation to this. Now here is a cycle. A straight line drawn from the center of a cycle. So this is the center of a cycle. A straight line drawn from the center of a cycle to bisect a chord. We will explain what a chord is. A chord is a straight line from circumference to circumference. And they clearly said it. A straight line drawn from the center of a cycle to bisect a chord. So let's draw the straight line from the center of the cycle. This is the straight line drawn from the center of a cycle to bisect the chord, that is to divide the chord into two equal parts. That very chord, which is not a diameter, is at right angle to the chord. So this very straight line is at right angle to this chord. Right angle, that is at angle 90. Fine. So now let's just get a triangle here. If I have my radius, this is a radius, this is a radius. We said it earlier, a radius is a straight line from the center of a cycle to the circumference. We have a radius here. This is radius. This is center O. We can call this point A. We can call this point B. And then this midpoint, we can call it point M. So that's the theorem. A straight line drawn from the center of a cycle to bisect a chord. This is a chord, this very line here. To bisect it, that is to divide it into two equal parts. This very chord, which is not a diameter, is at right angle, 90 degrees. That's what the theorem says. Let's have example 1. Example 1. A chord of a cycle is 12 centimeters long. The radius of the cycle is 10 centimeters. Calculate the distance. Calculate the distance of the midpoint of the chord from the center of the cycle. Let's solve this question. We'll draw our cycle as usual. Please, anytime you're solving this type of problem, make sure you draw the cycle. Make sure you draw the cycle. Now let's analyze the question. A chord of a cycle is 12 centimeters long. Let's draw the chord. Where's the chord? This is the chord. The chord is 12 centimeters long. 12 centimeters long. This is the center of this cycle. The radius of the cycle is 10 centimeters. What is radius? The distance from the center of a cycle to the circumference. So if we draw the radius, we are going to be having a line like this. And they said the radius is 10 centimeters. Let's draw the other side of the radius. Calculate the distance of the midpoint of the chord from the center. So from this center, let's calculate the distance of the midpoint. Distance of the midpoint. So since we divide this in the midpoint, it means this 12, that is from here to here, which is 12, has been divided into two equal parts according to this theorem 10. So this place will be 6. This is that 12 has been divided into two equal parts. That will be what? 6. This is a right angle here. So from here to here is 6. From here to here is 6. And this is our 10 centimeter. The question is now asking us to find the length here. So I can use the letter X for it. Calculate the distance of the midpoint of this chord from the center. So we are asked to calculate this distance from here to here, which I'm using X for it. And from what we have here, we have a triangle here. If you look at it, we have a triangle. I will bring out the triangle and use Pythagoras theorem for it. Here's the triangle. I will bring out this triangle and use Pythagoras theorem to solve it. We have a triangle here. So you can see from here to here is 6. This is our 6. Here to here, that is the very hypotenuse, which is 10. That's the radius. And then here to here, that is what we are to find. I can use Pythagoras. What did Pythagoras say? The square of the hypotenuse. The hypotenuse is the longest side. That's the side that is facing the 90 degrees. The side facing 90 degrees is the hypotenuse. Hypotenuse square equals to opposite square plus adjacent square. That's Pythagoras theorem. So if you know your hypotenuse, the other two, you can call any of them opposite and call the other one adjacent, or vice versa, no problem. So putting the values, our hypotenuse here is 10. That is 10 square equal to x square, that's this very side, plus the other side, which is 6 square. This one is representing this one is representing this. Let's move on. 10 square means 10 in two places. 10 square means 10 times 10. This is your equal to x square plus 6 square means 6 in two places. 10 times 10 is 100 equal to x square plus 6 times 6 please. 6 square means 6 in two places. 6 times 6, 36. At this point, we'll collect like terms. That is to say, this number will have to go across to go and meet its fellow number. That is this very number here will go across. So since it is positive, when it goes across, it will go and become negative. So we have 100. When plus 36 comes, it becomes minus 36 equal to x square. 100 minus 36 is 64. 64 equals to x square. To get x, we need to remove this square. And to remove square, you take square root of both sides. The square root that can cancel square. So you have your 64 equals to x square, square root, square root. Square cancels square root, you are now left your x. Square root of 64 is what? Square root of 64 is 8. So therefore x equals to 8 centimeters. So the distance from the center to the chord is 8 centimeters. Let's solve the second example and stop the examples here. Example 2. Example 2. Calculate the length of a chord of a cycle of radius 26 centimeters. If the chord is 10 centimeters from the center of the cycle. Just as usual, the first thing we'll do is to draw our cycle. When we draw our cycle, we'll now bring out the triangle and then use Pythagoras theorem to solve it. It's as simple as that. So we're trying to get our cycle. We have drawn a cycle. Now let's do the analysis. Calculate the length of a chord. Here's our chord. Then we want to calculate its length. Calculate the length of a chord of a cycle of radius 26. Let's get the radius. Of radius 26. So this is the center. This is the radius 26. If the chord is 10 centimeters from the center of the cycle, so from this center down to the chord is 10 centimeters. We have to find from here to here, because the question said calculate the length of a chord. So we are going to bring out one of these triangles. We'll bring out this triangle so that we can calculate from here to here, the length from here to here. Once we calculate from here to here, we'll times it by 2. That will give us the complete length, because the chord is from here to here, and here to here is half of it. So we just times it by 2. That will give us the entire length of the chord. Let's bring out our triangle here. This is our triangle. Here's our triangle. This is a right angle triangle. This is this very 26 here. Here is 10. That's the 10 you're seeing here. And this place that we want to find, let's put x there. We'll make use of Pythagoras theorem to get this part. Pythagoras theorem says hypotenuse square equals to opposite square plus adjacent square. The hypotenuse is the longest side, that is the side that is opposite the 90 degrees. So we have our 26 squared equals to x squared plus 10 squared. 26 squared, that is 26 times 26 equals to x squared. 10 squared, that is 10 times 10. 26 times 26 is 676 equal to x squared plus 10 times 10 is 100. At this point we will collect like terms. If we collect like terms, this plus 100 will go to the other side, and when it moves to the other side of the equality sign, it will go and become negative. So we have 676 minus 100 equal to x squared. 676 minus 100 is 576 equals to x squared. So to remove this square, we'll take square root of both sides. It is only square root that can cancel square. So here's our 576 equals to x squared. Take square root, because what you do to the right hand side, you do it to the left hand side. Square cancels square roots, so we are having x, and 576, square root of 576 is 24 centimeters. So x equals to 24 centimeters. Why not true? This is just half. This is half of the chord. what we just finished calculating from here to here is half of the chord, that is from here to here. So the complete chord is twice of what we have just finished calculating. So the length of the chord, the length of the chord is now 24 times 2. That will be 48 centimeters. So thank you for your patience. I'm going to give you some work to do. I'm going to leave you with work. You will solve these questions for me as assignment. Question number 1. The radius of a cycle is 10 centimeters. The length of a chord of the cycle is 16 centimeters. Calculate the distance of the chord from the center of the cycle. If your work is correct, your final answer will be 6 centimeters. Question number 2. The distance of a chord of a cycle of radius 5 centimeters from the center of the cycle is 4 centimeters. Calculate the length of the chord. If your work is correct, your answer will be 6 centimeters. The last question. Question number 3. A chord of length 24 centimeters is 13 centimeters from the center of the cycle. Calculate the radius of the cycle. If your work is correct, your answer will be 17.69 centimeters. Do well to snap your work and let me see it, and then upload it on 08061573528. That's my WhatsApp number. And do well to hit the subscription button so that I will keep you notified whenever I release a new video. Thank you and have a nice day.